No problem, huh? So this is an algorithm. Look at this example. Now, for the Prim's algorithm, the graph given here, there is a weight from each vertex to another. So what we want to do is, let's say we start from vertex D. So the first thing you need to do is you find the edges that is connected to D, like just now, but this time you need to write out the weight. For example, now D is connected to A, B, E, and F, right? So you need to write out the weight from D to A, which is 5, D to B, which is 9, D to E is 15, and D to F is 6. Only 4, right? D to F is 6. So from the 4 here, what we want to do is find which one is a minimum weight. We can see that the minimum weight from D to A is the minimum, right? So that means the first one we will choose is AD with the weight of 5. Actually, this one there is a color. So your copy, you got color, no? In my slide, but not this one. Okay, so whenever we choose the one, then it will change color already, but here cannot see. Never mind. So we have the first one is DA is 5. Then after that, we will bring the A that we have chosen to our second row. Now, bring it to the second row and delete the column A. No more column A here. So next time, the next table, you need to copy down the D to B, still the 9 here, same. And then D to E, you have 15. And D to F, you have 6. Now you need to do for A. A connected to B, 7. Only B, right? Yeah. Then after that, from the second table, what do we need to do is find from the row D and row A, which one is minimum? Six is the minimum, right? So meaning that in the table here, we will choose DF as our second edges that we will include in the 3. So we have DF equal to 6. Now, the third row, repeat the same thing. Include the F now in the third row here, and the column F no more in the column already. So we have DAF, and here is B. DB is still 9. DE is 15, so no more F already. AB we have 7, and now we need to do the third one, F. F connected to E. E is what? The soft copy also cannot see. F to E, right? 8, right?
Oh, 8, yeah, it's 8. The first image.
F to E is 8, So here F to E is 8. Any others? F to G, right? F to G is 11. Any more? No more. Okay. Which one is minimum here? AB is the minimum. So we have 7. Okay. Now include the B to the 4th row. Left the DE is 15. So no more column B, Then A no more already. F, you still have FE, which is 8. FG is 11. How about B? BC is 8. And then BE, 7. That's all. Minimum 7. So we have BE equal to 7. Now E become the 5th row. So we have DE, no more already. FG. FG is 11. BC. BC we have 8. E go to C 5. E go to G is 9. Minimum 5. Okay, EC 5. Include the C now in the 6th row. So we have D, FG, right? FG is 11. What else? EG 9. C. C don't have already. So minimum will be EG 9. Okay? No more column already can be added, right? So that means we already choose all the minimum weight from the vertex D just now. Then go back, add up all, and draw the minimum spanning tree. The edges that you have found just now. You draw out all the edges. Can, right? Follow the diagram given, the original diagram. Which edge you choose, you draw the edge just now. That is your minimum spanning tree. Okay? What is the first edge? The AD, right? Okay, so I draw here. You tell me, first one is AD. 5, right? And then DF. DF is what? 6. Then AB. Seven. BE. E7. EC. 5. EG. EG9. That's all? Okay. So we have this as our minimum spanning tree, and the minimum total weight will be equal to what is the minimum total weight? 39. Okay, so this is using the Prim's algorithm to find the minimum spanning tree. You understand the step, right? Now, a bit tedious lah. You need to know to do all the table here. So the more edges given, the more table you need to construct. Cannot straight away cancel, then give me the answer. You need to show all the algorithm by showing the table one by one. I know you see the graph like this, you can straight away choose the minimum weight, right? But that is not our objective, because normally, actually by right, the graph is a complicated graph. But because I want to show you the steps, that's why we use a simple graph to do. This algorithm is run by the program, so the graph given is a very complicated graph to get the minimum spanning tree. Okay, so you need to follow the steps, how to get until the minimum spanning tree here. Of course, when you do it manually, the graph given will not be so complicated. The one that you can do. Okay? Now, you have another example here. This one is the one to construct the bicycle path. So they want to minimize the cost. And these are all the costs, let's say, in between every vertices. You see here, A, B, C, D, E, F, G, H. So you have all the costs given here. And you use the Prim's algorithm to find which way they need to follow in order that the cost that they will pay will be minimum. Can you do that? Follow the step just now. Okay, using the Prim's algorithm. Now, did the question ask you start from which vertex? No, right? Then up to you lah. Which one you want to start from? Which alphabet you like most? Then you start from that one. Okay? Can you do that? Or you want me to do together? Huh? You do first.
所以那边刚才，那边菜。
你在滴水啊，或者他吃，做不做？能做。那你在听歌不呢？那我在学习啊。When there is the cost or the weight which are the same, right? You can choose either one. The minimum total weight, it will be the same, but when you draw the minimum spanning tree, it can be different. So like just now I give you the example of the graph and you draw the spanning tree. You have many different spanning tree, remember? So the spanning tree can be different as long as your minimum total weight is the same. So no problem, huh? You can have alternative answer for the minimum spanning tree, but not the minimum total weight.
下来，有异样啊，异样，就选一个，随便选一个，either one。
炸就好了。越多要怎样？